All right. Well, good afternoon, class. Hope everyone's doing well. Um, Hope you had a nice weekend. I had a really nice weekend myself, and this looks like the weather's warming up a bit, and I spent some time outside. Um, and let's see, I've got a heavy mileage week where I'm going to be running 80 miles this week. So um, that means that some of my lessons might be a little bit later this week because I have to spend more time running in the morning. Hey, Ethan. Hey, Rourke. Let's get down to physics. Yeah, physics. Oh, I watched a pretty disturbing movie on Netflix. It's called what is it called? The Platform or something like that. And it's like there's this platform that has food on it, and there's all these levels, and whoever's at the top level, they get the first pick of all the food that's on the platform. And then the platform like moves down to the lower levels, and if you're at the lower levels, then you don't get any food. um, and it's like a horror movie. So it's like someone just wakes up and they're in this prison where there's this platform. It's kind of interesting. Don't watch it if you have any fear of cannibalism. Is all I have to say. All right. So what are we learning about today? Today we are learning about something called the Sudoku method. Okay. And if you look up Sudoku method of circuit analysis, you're not going to find anything because that's just what I call it. I call it the Sudoku method because it reminds me of playing Sudoku. But you won't find it under any textbook or anything like that. So this is just a method of circuit analysis that is useful in circuits where you have one battery and a lot of resistors. So if you have one battery and a lot of resistors, you use the Sudoku method. If you have multiple batteries, then you've got to use Kirchhoff's laws. But if you have just one battery, then the Sudoku method is useful. So let me tell you the Sudoku method. So what we have here is I've got a circuit with a 12-volt battery, and I've got some resistors. There's a 5 ohm resistor, a 2 ohm resistor, and a 1 ohm resistor connected like this. Okay. So what I'm going to do is I'm going to make a table of V, I, and R. Okay. And I'm going to have one row for each thing in the circuit. So I can see there's a battery, and the battery produces 12 volts. So and I'll put V parentheses, V for the units. So if I put V in parentheses up here to tell me the units, then I don't have to put it down here. So this is 12 volts. Okay. I'm going to assume that this is an ideal battery. So I'm going to ignore the resistance of that battery. Okay. And then I also have this 5 ohm resistor. So 5 ohms. I've got this 2 ohm resistor, and I've got this 1 ohm resistor. Okay. So there you go. Now, what do we do with this Sudoku method? Well, the first thing you want to do with this Sudoku method is you want to determine the current flowing out of the battery. Okay. So how much current is flowing out of the battery? Well, if we look at this battery, what does the battery see? It sees 3 resistors, and you can see that this branch of the circuit is in parallel with that branch, and these 2 resistors are in series. So basically the resistance of this circuit, as seen by the battery, is 5 ohms in parallel with 3 ohms. Okay, 5 ohms in parallel with 3 ohms. So the resistance of the circuit is 5 ohms in parallel with 3 ohms. I'm not going to work out the math for that just since I've already done that a lot in the previous lectures, but so rest assured that it is 1.9 ohms. Okay, so that's the resistance that the battery feels. Then we use V equals I times R, Ohm's law. The battery voltage. Hey, Aisha, you're in the wrong lesson, but you're welcome to stay and watch this lesson on the Sudoku method. So V equals IR. So the voltage is a 12-volt battery, and the resistance is 1.9 ohms. So I can get that the current flowing out of the battery is 6.4 amps. Okay, so I've got this table here. Okay, and so the battery's current is 6.4 amps. So this is the row for the battery. So for the row for the battery and the column for current, I'm going to put 6.4. Okay, so there you have it. Now, what we have to do is we have to use KCL or KVL or SIPOV to fill in the table. So it's just whatever observation you can make. So now one of the things I notice is that the battery is in parallel with the 5 ohm resistor. The battery is in parallel with the 5 ohm resistor. How do I know that? You can see this wire splits. This wire, it comes in, it splits, it goes through the 5 ohm resistor, it goes through the battery, and it comes back together. Okay. So that means that those are in parallel. Another way you can see that they're in parallel, okay, is that if I do a Kirchhoff's voltage law loop, it only has these 2 things in it. If I go around that loop, it only has resistor and battery. So if you can draw a loop in the circuit with only 2 things in it, then those 2 things are in parallel. Okay, so these 2 are in parallel. So for the row, for the 5 ohm resistor, it's in parallel with the 12-volt battery. And according to SIPOV, parallel things have the same voltage. So this would have to be 12 volts. Okay. So I just use SIPOV to fill in part of the table. Now, anytime I have 2 parts of a row, I can use Ohm's law to get the third part. So using V equals I times R, we've got a 12-volt battery, or 12, the voltage is 12, and then the resistance is 5. So I get the current is 12 over 5, which would be 2.4 amps. So I'll put in 2.4 amps here. Oops, I don't need to put amps because I already put it up there. All right. So there we go. So notice how if I look at this junction, I had 6.4 amps coming out of the battery, of which 2.4 of it went through this 5 ohm resistor. So according to Kirchhoff's current law, the current flowing into this junction has to equal the current flowing out. So if 6.4 amps are going in and 2.4 went that way, then the rest of it would have to go this way. So this would have to be 4 amps. Now, see how the 2 ohm and the 1 ohm are in series with each other. So according to SIPOV, series things have the same current. So these two resistors, they both have a current of 4 amps. Okay? They both have a current of 4 amps. So I used KCL and SIPOV to determine those currents. Now, anytime I have a row with 2 things filled out, I can get the third one with Ohm's law. V equals I times R, so this is 8 volts, and this is 4 volts. All right? So we can do a little sanity check. What if I did a Kirchhoff's voltage law loop around the outside of the circuit? Like that. You can see I have a 12 volt rise, and then across the 2 ohm resistor I have an 8 volt drop, and then across the 1 ohm resistor I have a 4 volt drop. So by completing the loop I have a total change in voltage of 0. So Kirchhoff's voltage law is satisfied. So hopefully you can see why I call this the Sudoku method. It's because, right, in Sudoku you have a grid, and you fill in, you have a couple of things filled in to start, and then you're able to deduce what the other spots in the grid are, what the numbers are, based on what you've already filled in, and some rules for the game. So that's why I call it the Sudoku method. We're going to do one more example, which I already drew. I actually did some preparation this time. So let me make my table. My table is V, I, and R. Okay. I've got a 9 volt battery, which doesn't have a resistance. I have a 6 ohm resistor, a 4 ohm resistor, and a 3 ohm resistor. So there it's filled out and ready to go. So my first step is that I want to determine the current that flows out of the battery. So let's figure out, first of all, what is the total resistance of this circuit? Okay. The total resistance, you can see that this circuit has a resistance of 3 ohms in series with 6 and 4 in parallel. So I could write that as 3 plus 6 in parallel with 4. Like that. That's a total resistance of 5.4 ohms. So now, doing V equals IR, the battery has a voltage of 9 volts. The current is unknown, and the resistance is 5.4 ohms. So I can do that division, and I get a current of 1.7 amps. That's the current that is flowing out of the battery. Okay. So this is 1.7 amps. I can fill that into my table. Okay. Now, notice that the 3 ohm resistor here is actually in series with the battery. See how it's the battery and then one wire connects them to each other. So they are in series. So according to SIPOV, the 3 ohm resistor must have the same the 3 ohm resistor must have the same current as the battery, according to SIPOV. So I can fill this in as 1.7. Now I know two parts of a, I know two numbers in a row. So I can get the third number using Ohm's law. V equals I times R. So V equals 1.7 times 3. So that is what, 5.1 volts. This would be 5.1 volts. All right. So there's a 5.1 volt drop across this resistor. So how do we proceed from there? Well, we're always going to, if you get to a point where you're stuck, the way you get unstuck is you use Kirchhoff's voltage law or Kirchhoff's current law or SIPOV. That's how you get unstuck when you're solving Sudoku method problems. So I'm going to do Kirchhoff's voltage law, and I'm going to go around this loop like that loop right there. Okay. And notice for that loop, the sum of the voltage changes has to be 0. So notice how I have a 9 volt rise across the battery. And then I have a drop across this 6 ohm resistor. And then I have a drop across the 3 ohm resistor. And then I come back to where I started. I know the drop across the 3 ohm resistor is 5.1. So I can, it's just those three things in the circuit, or in that loop, excuse me. So that allows me to solve for the voltage across the 6 ohm resistor. Okay, and that tells me that V equals 3.9 volts. So the 6 ohm resistor gets 3.9 volts. Does not get the full voltage of the battery. Now I'm going to use SIPOV. The 6 ohm and the 4 ohm are in parallel with each other, so they have the same voltage. So this one also gets 3.9 volts. Then in this row, I can apply Ohm's law, and in this row, I can apply Ohm's law. It's all coming together now. So V equals I times R. 3.9 equals I times 6 will give us this current. And then 3.9 equals I times 4 will give us this current. So let me do the math on that really fast. This is 0.7 amps, and this is about 1 amp. Okay. I'm doing some rounding here. Now, so I've completely filled out the table, so I've solved the problem. And then I can use Kirchhoff's laws to verify my answer. So for example, I know that 1.7 amps comes out of the battery, and I know that the 6 ohm resistor gets 0.7 amps, and I know that the 4 ohm resistor gets 1 amp. Does that satisfy Kirchhoff's current law for this junction? Yes, it does. Why? Because I have 1.7 amps going in, and I have 1 plus 0.7 going out, which is also equal to 1.7. All right. So that is the Sudoku method. This is a tough method. Students have trouble with it, so I'm going to be spending today through Wednesday doing Sudoku method problems. Um, and then we'll just have a few circuit odds and ends for Thursday and Friday, and then we'll be done with circuits for spring break. So I hope you guys have a nice rest of the day, and I will talk to you tomorrow with more Sudoku Method. Bye now.